Hello, everyone. Thank you all for joining us for this Microsoft Reactor live stream event. We are happy to have Carey Payette here, a senior software engineer with Trillium Innovations, joining us today. Carey will be covering from device to dashboard, the Voyage of IoT Data in Azure. The session will run for approximately 60 minutes with time for questions throughout and also a little bit of a Q&A window at the end of the session. Do feel free, however, to drop your questions whenever they come up into the chat. We're happy to, scout them or, eventually we will get to them at the end. If this is your first time joining us, please note that there is a slight delay in feed from our broadcast to the YouTube channel. So if there's a little bit of a delay in answering, again, we'll get to them eventually, I promise you. Also to note, the session is recorded and will be available later on YouTube on demand. So you will be able to find this session and access it at another time in the event that you can't stay for the entirety of the session or if you join us a little bit later. Also, at the conclusion of the session, I will be sharing a feedback survey. We use those surveys to figure out future content. So please do, if you have the opportunity, fill those out. We really appreciate any feedback, tips, what you want to see, anything like that. So do let us know. At this time, I'm going to have Carey step up and she'll take it over from here. Hey, Carey, thank you for joining us.
Hi, thanks, Rebecca. Thanks for having me today.
Of course.
I really appreciate the introduction. So welcome, everyone. I hope you're having a fantastic morning, evening, afternoon, whatever time of day it is for you. So as Rebecca mentioned, I am Carey Payette. I'm a senior software engineer with Trillium Innovations. I'm also a Solliance partner. I'm an Azure MVP, and I'm heavily involved with delivering and creating training curriculum surrounding multiple Azure technologies. So thank you for joining me in this session where we're going to take a look at the Voyage of IoT data in an Azure solution. So we're going to review a simple lambda architecture to trace the route of data from the device to a real-time dashboard. So let's go ahead and begin with a scenario. So put this in your mind. You own a chain of automotive service locations. Your goal is to ensure the health and safety of your employees. On premises, each store is equipped with an air quality sensor and a matrix portal, which is a small microcontroller device. This sensor and matrix portal will display the overall quality of the air in the shop. These devices are registered as IoT devices in the IoT Hub, and the IoT Hub will essentially provide it a device connection string that we're going to actually store on the device in a secrets file so that the connection can be made from the matrix portal into the IoT Hub. So the matrix portal itself will read the raw sensor data and forward it through the IoT Hub through a device to cloud message. The IoT Hub exposes what's called a consumer group, and this consumer group is made specifically to be ingested by the Azure Stream Analytics service. This way, we ensure that there's going to be no contention for the messages and that the Stream Analytics service will receive all messages. We're then going to focus on the cold path. So from this Azure Stream Analytics service, it's going to output all of its raw data into Azure Data Lake storage. Their Synapse Analytics will trigger a data pipeline every hour to further transform and refine the raw data in the data lake and store it in Azure SQL. Finally, we're going to be able to use a parameterized historical data report based on that data and view that data in Power BI, reading that from a SQL server. So let's go ahead and just kind of backtrack just a little bit and talk about the hot path. Azure Stream Analytics has the ability to output to a streaming data set in Power BI. And what this gives you is that really important real-time dashboard experience. So essentially the data comes in, it's immediately pushed into Azure Stream Analytics, which immediately populates that Power BI data set. So this will give you that real-time dashboard functionality. So let's go ahead and investigate now each major step of this voyage. So we're going to start with our hardware. So you probably already know that there's just tons and tons of various microcontrollers that you can leverage on the market today. For this session, I'm going to be using the Adafruit Matrix Portal M4 board and an accompanying air quality sensor. So at a high level, the Matrix Portal is actually typically created for powering and controlling LED matrix displays. Today, we're going to be using it in a slightly different capacity. We're going to use it to capture telemetry for us to ingest into our Azure solution. So a little bit about this board is it has a SAMD 51J19 Cortex M4 processor. That's a mouthful, with 512 kilobytes of flash and 192K of SRAM, and it supports both Arduino and CircuitPython programming. For internet connectivity, it has an onboard ESP32 Wi-Fi coprocessor, which supports things like SSL, and it actually communicates with the other board using SPI. The Matrix Portal also has an I2C stemma connector. And what this is really nice is because we're able to connect our air quality sensor, which I'm going to show you here in a moment. And you don't have to fiddle with anything like wires or soldering. The air quality sensor that we're going to be using today is the Adafruit PMS-A003i. This sensor communicates using I2C through that stemma connector and produces a data stream that updates once per second. So it provides things like the PM10, PM25, and the PM10 concentration in both standard and environmental units. Particular matter per 0.1 liters of air, categorized into 0.3 micrometers, 0.5 micrometers, 1 micrometer, 2.5 micrometers, 5 micrometers, and 10 micrometer size bins, as well as a checksum in binary format to make sure that that stream isn't tampered with. So I see a question here is, if I didn't require real-time reporting, can I skip the stream analytics service? Can I just take the output of the IoT Hub and store it in the storage account? Absolutely. One of the outputs you can definitely do is store that directly into the storage account if that's what you need to do. Yep, that's fine. All right, so let's go ahead and move to a quick hardware demo. So I'm going to switch to from my face to an overhead camera. So this camera here, you can see that's my hand, it's live. It's showing my hardware that I have currently set up. So here you can see that we have our Matrix Portal, and on the Matrix Portal you can see the Espressif. This is the actual Wi-Fi connector. It's a coprocessor. So technically it's like a microcontroller and a microcontroller, and it communicates between the two using SPI. Now this connector right here, this is the stemma QT connector. So one of the things you'll notice is that this sensor is equipped with that QT connector as well. So I didn't have to do any soldering or anything. I just used the stemma QT connector to connect each side, and it communicates with the Matrix Portal using I2C. So that's just a quick overview of the hardware that I have currently executing on my desk right now. So I'm going to go back. There, I'm back now. So let's go ahead and come back to the presentation. All right, so let's talk a little bit about what we're measuring here today. So PM stands for particulate matter, also called particle pollution. So it's a term of the mixture of solid particles and liquid droplets found in the air. So some particles you already know that you can already see are things like dust, dirt, smoke. Those are large and dark enough to be seen with the naked eye. Others are so small that they can only be detected using an electron microscope. So particle pollution includes, for instance, PM10, which is inhalable particles with diameters that are generally 10 micrometers and smaller, and PM25, which are fine inhalable particles with the diameter of 2.5 micrometers and smaller. So you might wonder, well, how small really is 2.5 micrometers? So you can think of a single hair from your head. So the average human hair, not the head, the hair, is about 70 micrometers in diameter. So if you think about it, that means your hair is 30 times larger than the largest fine particle that is being measured by the PM25. So let's make a shift now to programming. So in this demo, I've decided to use CircuitPython to implement the code. And my editor of choice in this case was Mu, but really any type of text editor or IDE will work. A lot of people also like using text editors like VS Code. So what I'm going to do is I'm actually going to bring up our code so we can walk through it together. All right. So CircuitPython is really nice that it reduces the barrier of entry for programming microcontrollers. When you plug the device into your machine, it displays similar to what you would see as like a USB drive. So I'm going to go ahead and bring up my file explorer here, and you can see, if you can see in this resolution anyhow, that I have my computer and it has an iDrive called CircuitPy. So essentially all I had to do to set this up was connect it to my machine, and then I downloaded a CircuitPython image that's made specifically for my board. So that can be found through the circuitpython.org website, and you can see that we have there's images made for specific boards. I just downloaded the UF2 file and I moved that onto that file share that was created. And then essentially it flashed it the way that it needed to be in order for it to run the operating system. The next thing that I really want you to pay attention to is some of the files that are available on this drive. So the ones that I want to call out here are secrets.py and code.py. So secrets.py, I'm not going to open it here for you, and that's because it has my secrets in it. So this is going to be code that you want to keep secret. So we want to make sure that we don't check that into source control. So that's going to contain things like my SSID username, or sorry, my SSID network name and my password, and it also contains the device connection string for Azure. So I'm going to show you how to get that value from IoT Hub shortly. So the second file is the code.py, and I'm actually going to bring this up here. Rebecca, if you can let me know if you can see the source file okay, that would be great. I just want to make sure this is more important than seeing the actual.
Hey, yeah, that
Okay.
looks like it's coming in. You could zoom in just a little bit, and then
Okay.
otherwise the browsers would be fine.
Yeah, I think that's as big
That's
as I
good,
can
yeah.
go. All right, no problem. All right, so code.py is the name of the file that you want to have execute automatically when the device is booted. So every time the device senses that this file changes, it'll actually reboot itself and start executing the new code. So just a quick overview of the actual source code. At the top of the file, you're going to see the imports. So these are some of the libraries that we would use within our program, and the libraries are stored on my CircuitPy drive. And I know it's small, but I'm not sure how to increase that in a file explorer. But the lib folder essentially has any libraries that you want to bring over onto your machine on your Matrix portal. All right, so after that, what we're doing here is we are initializing that Wi-Fi connection. So you're going to see that we are talking to that ESP32 coprocessor, and we're opening up a Wi-Fi connection with the ESP32 using the secrets that I have in my secret file. So again, that has the SSID. It also has my Wi-Fi password as well. All right, once it's actually connected to Wi-Fi, I go ahead and I talk to an NTP service, and I actually synchronize the time that's on the device with the NTP time. So that is that. The next thing that we're doing is connecting to the IoT Hub itself. So the IoT Hub device goes ahead and uses the ESP and connects using the device connection string, which again, I'm going to show you how to retrieve here in a moment. And it's going to use that device connection string to connect to our IoT Hub and connect to it. After we've got that connection made, we are going to then initialize communication into our sensor. So again, we are using I2C because it's using the STEMMA QT connector. And we are initializing, there's another helper library for this sensor itself called the PM25 I2C. And so we initialize our communication to that sensor as well. Then we enter a while true loop, and you're going to notice that there's no real break in here. So that's going to run forever, and that's what I want it to do. So every 30 seconds, what it's going to do is read the data from the sensor. So if you remember, it's going to be returning particulate matters measures for multiple buckets. So like 2, 5, and 10, for instance. What I'm also doing here is I am adding 2 additional pieces of information into that data that we're retrieving. So I'm adding the matrix portal as a device ID field, and I'm also adding a timestamp field using the current time. Lastly, of course, we're going to use the device to send the device to cloud message. So essentially report that telemetry up into the cloud. So if you probably noticed down below here, I have a REPL, and every 30 seconds, you'll see that it's reading sensor values and essentially sending that up into the cloud. So you can see it's using MQTT in this case, and it's sent this message in. So you can see it's sending P10M, particles 0.5, and particles 0.3, and so on. Now this second message here, it's actually just looking to see if there's any cloud to device messages, which I'm not actually sending any in this situation. But if we needed to, for instance, sound an alarm or blink something on the device to indicate that some specific threshold has been met for the pollution in that environment, you can definitely have some type of function, if you will, send a cloud to device message to initiate that type of alert. All right. I also wanted to show, and of course you can see it here, we are using JSON data. So the data that's being passed in is JSON formatted going into the IoT Hub. All right, so let's now talk a little bit about the data ingestion. All right, so we've already seen a small preview of data ingestion with our matrix portal code connecting to the IoT Hub using that device connection string. So this is only one way to connect to IoT Hub, and it's typically the recommended way to do it for development scenarios. Now, when it comes to production devices, I recommend using the Azure Device Provisioning Service, or DPS. This will allow you to register and manage large numbers of devices through automatic provisioning. DPS also provides load balancing, geo-sharding, and enables scenarios such as solution isolation and multi-tenancy. So the next step along this line is Azure Stream Analytics. This service is configured to receive all incoming telemetry from the IoT Hub. This service allows you to write SQL-like queries to direct data that matches specific filters with their appropriate output. In our case, we're interested in landing all data into the code path storage in ADLS Gen 2, but at the same time, we want to land all incoming data also into that real-time Power BI dataset. So let's go ahead and step a little bit into the ingestion piece. All right, let me switch back to my browser here. All right, so let's go ahead and we're going to start with the IoT Hub. So within my Azure subscription, and let me see if I can bump this up a little bit. All right, within my Azure subscription, I have a Device Hub 1, which is an IoT Hub. So let's go ahead and open that. You can see that it's currently being used, and you can see the connected devices. But because we are using the connection strings that we're using in the secrets.py file, we actually need to register that device ourselves. So the way to do that is through this IoT devices section. And you can see that I have two devices that are created, but of course the one that we're working with today is the Matrix portal. So I can go ahead and select that one. And here is where you're going to find a bunch of device information. So here you can see the Matrix portal, and then there's also primary and secondary connection string. And this is the value. Essentially, you can copy it to your clipboard and put that into your secrets.py. All right, so let's go ahead and go back to my device hub, and let's talk about the actual outputs of the device hub. So in our case right now, we want to create what's called a consumer group. And consumer groups are found in the built-in endpoint section. And let me scroll down just a little bit here. And here you can see the consumer groups that we have defined. Now, the reason why we do this is because if you have multiple services reading from the same consumer group, you can't guarantee that each service is going to get each of the messages. So if you create a consumer group for each item that's going to be reading the stream of data, you can be sure that that Stream Analytics is going to be able to read all of the data coming in. So you can see here that we created a consumer group called Stream Analytics, and that is reserved specifically for our Stream Analytics input. So while we're on the subject of that, let's go ahead and go back to our resource group. And let's talk a little bit about our Stream Analytics job. So here you can see I have SA Air Quality. It's my Stream Analytics job. And you can see that there's one input and two outputs and a query. And of course, we have different running indicators, just making sure that things are up and running and healthy. All right, so let me tell you a little bit about Azure Stream Analytics. So Azure Stream Analytics is a powerful service that you use for real-time analytics of streaming data. So it's that first stop to identifying things like emergency scenarios. And it also has things like built-in anomaly detection to detect things like spikes and dips. But again, if custom coding is more your style, Azure Stream Analytics also allows you to apply custom machine learning models to this data, as well as executing code using user-defined functions. So let's go ahead and review some of the main components of this service. So the first thing that I wanted to talk to you about was the inputs. So we know our input right now is our device hub, but the inputs could be anything. It could be Event Hub, IoT Hub, or Blob Storage, or ADLS Gen 2. In our case, we created an IoT Hub connection to our device hub. And if I open this up, you can see, of course, it's grayed out right now because it's running, but you can see that I'm connected to my device hub 1 and that we are reading from that specific provisioned consumer group, Stream Analytics. Again, that's reserved consumer group for our Azure Synapse Analytics service. All right, so from that input, we essentially have a query. And what a query does is it's SQL-like syntax. And in our case, well, again, this is kind of an easy scenario because we're interested in sending our data, all of the data, incoming data, to both of our outputs. So here you can see that we have select star, which is basically saying select all of my incoming data. And again, you're not limited to just one input. If you had streams coming from 5 or 6 different places, you can aggregate them here and perform any logic that you need to. In our case, though, of course, we have the device hub, and we're going to select all incoming telemetry, and we are going to send that to the air quality store output, which I'll go over here in a minute, but that's essentially our storage. And we're going to say select star from our input, which is device hub 1, which again is our IoT hub. And we are going to do a filter saying where the connection device ID is matrix portal. Of course, right now, all the data coming in is matrix portal, but that's beside the point. But what I'm trying to emphasize here is that you are able to add filters, joins, add windowing to your data, however you need to implement your business rules at this point. The results of these queries are then directed to an output. So you can see that we're selecting from Device Hub, which is our IoT Hub, and we're selecting it into an output, which is Air Quality Store. And we also have a real-time Power BI output as well. All right, so let's take a quick look at the outputs. So the outputs can be multiple different types as well. So we have our air quality store, which is our blob storage, which is currently connecting to our ADLS Gen 2 account. And one thing that I want you to see is that I've added a stream pattern here. And the stream pattern, which I'll show you inside of an Explorer here in a moment, essentially stores incoming data based off of the ingestion time by year, month, day, and hour. Some people add quarter in there too, depending on if it's like a sales situation, for instance. Another thing I want to highlight here is that we're currently outputting that in JSON format, but you also have the ability to output in CSV, Avro, and Parquet formats. So the second output is to the Power BI, and we're going to step through this a little bit more when we come to the visualization part of this presentation. So let's now take a peek at our cold path storage account. So that's our air quality store here. And let me open up Storage Explorer. Inside of our containers, you're going to see that we have IoT Hub, Stream Analytics, year 2021, month 4. This is in UTC time, so we're currently up to hour 22, for instance. And you can see that there's a JSON file that's being stored. So essentially what is happening is IoT Hub ingests that data, and through Azure Stream Analytics, it picks it up through the consumer group. Then it executes that query from the input, which was our IoT Hub, and it will store that data into our storage using that path that we specified inside of the Azure Stream Analytics output definition for our storage account. So again, Stream Analytics, year, month, day, and hour. All right, so let's go ahead and come back to our slides here for a minute. and talk a little bit, now that we've actually stored our data in our cold path, simply storing telemetry as files isn't very useful to the business now, is it? So the power of data is unveiled when you process the data for analysis and visualization. So it's quite common to create things like machine learning models based on historical data. And these types of models could then be applied to real-time incoming telemetry data to do things like identify impending maintenance solutions. So in our scenario, we want to process our cold storage data every hour because we have our data lake path structured by timestamp. We only need to process the previous hour's worth of data. So the way that we're going to accomplish this is by using a pipeline and a scheduled trigger in Azure Synapse Analytics. And the last piece we need is the final destination for that processed data. So this is where we've cleaned things up, we've transformed things into the form that we need them. It's now a queryable ready state. In this case, I've chosen Azure SQL, but of course, depending on the amount of data that you're working with, Azure Synapse Analytics also has extremely powerful SQL pools. So let's now walk through what this process looks like. All right, so let me go ahead and bring back up Azure here. Okay, so here is Azure Synapse Analytics. Let me see here, bump that up just a little bit. Okay. All right, we're going to begin with data transformation. In our case, we want to source data from our data lake and convert and transform the data so that it can be stored in that SQL Server table. And we're going to accomplish this by using a Dataflow. So that is going to be available inside of the Develop Hub. And I have a process air quality telemetry Dataflow available here. All right. So a Dataflow is a visual tool that will allow you to execute data transformations, joins, derived columns, perform aggregations, and more on data. So really, I could spend a week on it. It always starts, though, with a source data set, where, again, you can have multiple sources if you want to. There's not a limit on the number of sources, but you do have to have at least one, followed by a series of activities doing transformations. And it always ends with a sync data set. And again, you can also process multiple syncs as well. So here is a source right here, and here is a sync. So the source is going to be our data lake. So this is going to be the JSON data that Azure Synapse Analytics is storing into our data lake in JSON format. So one thing that I want you to notice here is that in order to be flexible to be able to pull just the hours worth of data, we actually parameterize this data flow. So inside of parameters, you're going to see a date to process, which is a string format, which has a date that includes the hour. This is just a default value here. So if you were debugging your data flow, you can preview some data, but this is just a default value. Essentially what happens is when a pipeline is triggered that uses a data flow, that trigger will pass in the current timestamp of the scheduled trigger. And from that, we will pick out essentially the path that we want to process within our storage account. So let's go ahead and take a look at what that looks like. So here's the wildcard paths, and we already know we're going to be in the IoT Hub, but what we're doing here is then building that path based off of the date to process parameter, and we're building it /year, take the current year, /month, take the current month, /day, take the current day, all the way down to the hour, which we are actually subtracting by 1 from the current scheduled date. So this date to process will actually contain the hour to be processed. And then we're going to pull every JSON file from that location. So that is how that is working. The next piece of, well, actually, let's show you the projection. So inside the JSON file is essentially the same data that you would see coming through in JSON format from Moo here, from our device. So you can see that these are the fields that are coming across. And because it is JSON data, there's also complex objects that have been interpreted. So on the projection, you can see that inside of the IoT Hub object are different fields as well. But what we really care about at this point is obviously the particle measurement coming in. One thing to notice here is the schema, because it is JSON based, by default, it tries to interpret everything as a string. So obviously that's something that we're going to have to transform moving up into our transformation and refinement steps. So change column types is essentially doing that. You can see that we have our PM10M, which is our environment and our standard measurements coming in. And I'm casting those using an expression, again, using expression builder to integer, grabbing that incoming value. Oop, I don't want to do that. Discard the changes. Probably not a good thing to overwrite that during a presentation. But anyway, so we're essentially casting a whole bunch of these fields to integer. And of course, we have a timestamp here as well. So you can see that this one is doing a to timestamp. This one has a, because it's coming in as a JavaScript timestamp, we have to do a little bit of finessing, if you will, inside of our expression. But essentially, that will bring us to a timestamp that is easily ingestible by SQL Server. The next one is a select. So this was a derived column. You could have also created like a calculated column, for instance, or entirely new columns. In my case, I was essentially just overriding them, if you will, to show different values. So you can see if I go to the inspect tab here, you'll see that my cast now shows that they're integer instead of string. And then inside of this activity is a select activity. And all I'm really doing here is aliasing the columns, so it's easier for me to perform the mapping. So I'm essentially moving what's coming in from the device and changing it to the field name, essentially, that's located in SQL Server. And that's, again, just a step I like to do to avoid confusion. But other features that you have is you're able to branch things, join things, do conditional splits, aggregate, surrogate keys, windowing, ranking, flattening. So all sorts of different activities that you can perform here. The next activity is an AlterRow activity, and this allows you to define rules off of what is allowed on your sink. In our case right now, I want to allow upsert. And the reason why I do this is because if I need to, for some reason, rerun any of the data processing, I don't want to end up with duplicate data. So what I want to do is, in all cases here, I want to perform an upsert operation. And then within our SQL Server table, I'm able to say, allow upsert, and then the key columns that'll base uniqueness is going to be based off of ID and timestamp. So let's take a moment now to look at the data sources that we have defined. So we know that we have one pointing to our data lake and one pointing to SQL Server. So I will come in to our data and link tab, and here is our raw telemetry. So again, that's pointing to our IoT Hub stream analytics area, and then the schema that interprets from the data that's there. And what's really nice is it says integer there, but when we pulled it into the Dataflow, it did not say that. It was saying string. So we did that cast. And the same thing goes for our SQL Server. So this is pointing to my Azure SQL database through a linked service. And it's pointing to my DBO air quality telemetry table that has the following schema. Again, a bunch of integers, device ID, which is varchar, and of course the date time for the timestamp. Okay, so let's go ahead now and come back to our data flow. So here's our data flow here. We've now got it from source to sink. Here's our sink and the mapping again. Because I named it the same, I always turn off auto mapping because you never know what it's doing. So I make sure that the device ID is being mapped appropriately. The timestamp is being mapped appropriately. Oh, okay. I think I'm sharing my screen right now, Pravi, so hopefully you're able to see it. But one thing that I'd like to make note here is that a data flow in itself is not executable. So you can't just run this. It doesn't run on its own in isolation. You need to run it in the context of a pipeline. All right. So a pipeline is also made up of a series of activities. So these can be control activities like if statements, conditions, loops. They can also be activities such as running an Apache Spark notebook, executing stored procedures in your SQL pool. In our case, we're going to be checking the existence of data for the hour being processed. And if it does exist, we will then execute our data flow activity. So inside of this pipeline, I've also parameterized it. So you can see the date to process is here. And again, this is just the default value. What I'm expecting when this pipeline is run is that it will use this value to check to see if that hour has a folder allocated inside of storage. So if I then select my Get Metadata, you can see the Dataset tab grabs my JSON row telemetry parameterized, which is just a data set again pointing to the same location. But in this case, what I'm doing is I'm grabbing the year portion, the month portion, the day portion, and the hour portion. And it's essentially checking to see if that path currently exists inside of my ADLS Gen 2. And you can see that the field list is that I want it to return is that if it exists. So what this is going to do is on this get metadata activity, one of the outputs is going to be whether or not this file location exists. Then it goes into an if condition activity. And this if condition checks the output of that previous metadata activity and pulls that exists value. So if it exists, so if it's true, then it will go into the true activity, and we don't have any activity in the false activities. We'll do nothing. So let's go ahead and dive into the true activity. And here you can see our data flow. So our data flow, again, is parameterized. So the date to process is going to be that parameter that is passed in through the pipeline, which again is passed in through the data flow, so it knows where it's processing data from. And then essentially it'll fire up, behind the scenes, it'll fire up a small little Spark cluster, and it'll do that data transformation, moving your data from that source, from your ADLS Gen 2, all the way to your SQL Server, and then it will stop execution at that point. So the last piece of the puzzle where this comes in is the actual trigger. So within the Manage Hub, you can see that I have an hourly trigger already defined. So I named it Process Air Quality Telemetry Hourly. And if I select this, you can see that it's scheduled to run every hour on the hour. So it started in December, and it's been running consistently ever since then. Now, the parameter itself, I've went into the code view here just so I could show it to you. The parameter is being set to the scheduled trigger time. Again, this is UTC, which is what my data is stored in as well. And I'm subtracting that hour. So again, at hours, subtracting 1 hour, so that I'm always processing the previous hours of data going into that data flow. the pipeline that then goes into the data flow. Whew. All right, so I know that was quite a bit of information in a small amount of time, but it's now time to take the last step in our journey. So that is data visualization. So in this Lambda architecture, we have two types of reports. So the historical report, where you can query for any time frame of data, and the real-time dashboard, which again, we know is being sourced on that hot path with by Stream Analytics. All right, so let's go ahead and move back into Synapse. And again, you don't have to do this in Synapse, but it's a fantastic integration if I do say so myself. I'm going to actually go into a linked Power BI workspace that I have and open up my cold path Power BI report. So again, this cold path is going to be loading data from our SQL Server. So this is the data that's been from our device through Stream Analytics through to our Azure Data Lake storage, picked up by an Azure Synapse Analytics pipeline, and processed into SQL Server. So this is being fed off of SQL Server. And if I wanted to select like the past 2 hours, for instance, I can do that, and I can grab 2 hours of information. I can do 3 hours information, and so on. And you can see that historical data being pulled in. Now, we have that second hot path scenario for our data visualization. And this is going to be actually fed directly through Stream Analytics. So let's go ahead and move back to our resource group here and open up our Stream Analytics job one more time. So one of the outputs that we have defined, so if I go back to our query here, again, we're selecting all data from our IoT Hub into our real-time PBI output. And this real-time PBI output is defined as a Power BI output. And essentially what I've done is I've authenticated as myself, but you can also use a managed service identity as well. And I'm asking it to create and manage a data set called RealTime Telemetry. So what's really nice about this is inside of Power BI, I didn't need to do any of this. So all I did was connected to my Power BI workspace, and Azure Stream Analytics actually creates that data set for me. So when I come back to my Power BI data set, you can see that we have in our data sets and data flows the real-time telemetry here. All right. And built off of that real-time telemetry, we've created a real-time dashboard. So let's see if I can bump this up a little bit. And because I've probably been on here for a while, I'm just going to go ahead and refresh this screen so we can see our real-time data coming in. So this data is essentially flowing real-time from our Stream Analytics. So again, I'm only sending data up every 30 seconds. So we have to give it a moment here to refresh. Oh, so you probably just saw it move there just a little bit. But I've built this visualization based off of that real-time data coming in. So again, that's just one extra way of letting people see on a dashboard perspective, data coming in real time. Again, that first stop, if you will, to identify any problems that might be occurring. So again, Stream Analytics, you can also set some of the built-in spikes and dips and anomaly detection. And you can also use like Azure Machine Learning integration with it as well to apply your own models based off that you've created based off of your historical reports to identify those emergency scenarios, if you will, for bad air quality coming into your shops. All right, so let's go ahead and come back to our presentation. So that shows us the complete journey of our data from the IoT device all the way to visualization in an Azure solution. So I really hope that you've gotten a lot out of this session, and feel free to reach out to me anytime on Twitter at Carey Payette. And you can catch me on streaming live coding on Twitch at Coding Bandit as well. So with that, I will open up the floor to any types of questions that you may have. Thank you, Polly. I appreciate that.
Okay. While we wait for a couple questions to pop up, if any come through, I'm just going to pull up my slide deck and quickly just share a little bit of information about the reactor. Thank you so much, Carey.
Thank you for having me.
So just give me 1 second here. Let's do this. There we go. And then, awesome. So yeah, if you all have not seen some of the other Reactor options, if you joined us from Meetup, but you weren't aware that we have a website, if you found our website, but you weren't aware that we had a Meetup, or you saw a post on Twitter, or however you came to join us for this session today, we're happy to have you, but we'd love to have you back. Do feel free to either visit our main website, microsoftreactor.com. We have 12 different physical locations around the world. But we also right now are running a lot of virtual sessions. So with those virtual sessions, depending on where you're located, times might work better for you than other times. So definitely, check out different areas, see the different topics. Maybe we're hosting a session on the other side of the world, but for you, the timing works. So definitely use the calendar on Microsoft Reactor. If you are close to one of our physical spaces, also consider signing up to meetup.com and visiting one of our Reactor locations. Eventually, we do plan to go back into a hybrid state. So you will have some virtual sessions still, but we may also have some in person. So tune in for that coming up in the future. We also have a newsletter, aka.ms/reactor email sign up. That newsletter, basically, we send out a month in advance for any events that we have for the following month on our calendar already for your local region and time zone. So if you'd like just one bulk email to let you know all the sessions that we have coming up, do think about and consider signing up for that. Email blitz. I dropped a survey into the chat. If you have the opportunity, we'd really appreciate you taking the time to kind of go through that and give us your feedback. Let us know what you'd like to see in the future. We offer all different levels of learning and workshops and various other types of sessions. So Q&A, ask an expert types of sessions. So if there's things specifically you'd like to see on topics we maybe haven't covered before, you'd like us to revisit, do fill out that survey. Let us know. We'd be happy to, in the future, put something together. And then let's pop back over to the Q&A here. Looks like we've gotten a few comments that came in.
Yes. So Alistair had mentioned that he likes to write all of his pipelines using the Data Factory SDK API, that he's not a fan of the GUI tools. So how do you maintain these GUI pipelines? So the good news is underneath the covers, the data pipelines infrastructure is actually the same code base as Data Factory. So I know that you can use the REST APIs. I'm not sure if I think there's definitely a PowerShell. I would imagine that there's an SDK, the same for Azure Synapse Analytics. But at the end of the day, it's the exact same thing. So it's like the regular JSON-based artifacts that you would check into source control and perform your CI/CD using like Azure DevOps, for instance. So I hope that answers your question. And Mitesh asks, what would I require if I'm trying to build a solution that tracks my internet speed on a real-time basis? So that you would need to have some sort of method to, you would require some sort of method to read your speed, and then you would then ingest that into Azure. So whether or not you want to do that, like if it's just you, I don't know if, putting up an entire IoT infrastructure is beneficial for that. You may as well just ingest it and transform it and put it directly into a database of some type. But you can definitely ingest into Azure to perform that tracking over time. So Alistair mentions you don't need REST APIs or PowerShell. It's all C#. Yeah, there's definitely C# SDK. I'm just not 100% sure. I haven't used a C# SDK with Synapse specifically. So that was the reason for that comment. But that's definitely something that's available either now or definitely in the future. But just rest assured that it is, if you are already using Azure Data Factory and want to move to Azure Synapse Analytics, that it is the same code base that is running everything underneath the covers. So hopefully that helps. So Alistair asks, is Synapse a wrapper for the Data Factory SDK? So no. So Synapse actually has an implementation of the pipeline and the Dataflow components, if you will, underneath the scene. So it's a first-class portion of Azure Synapse Analytics. Just know that, like if you take a look at the Azure Data Factory UI and the UI in Azure Synapse Analytics, you can see it's essentially the same product, but it is a copy of the code. So it is the same code base, but it's not the same product.
Awesome. I think that may have covered all of the questions. We can give it just an extra couple of seconds and hang out here for a moment. Thank you again to everyone for tuning in. Yep, Alistair responded. I guess that's what they.
Cool. Awesome. And if you have any more questions too, feel free to hit me up on Twitter. Yeah, Synapse is pricey. That's probably one of the reasons why you see that I was using Azure SQL versus the SQL pools, because I just didn't have enough data to warrant the SQL pool costs. And another thing too, like the data flows do run on a Spark cluster, so there is going to be some costs associated with that too. But essentially, as long as you're not running SQL pools, or even if you are, you can pause those SQL pools, right? So if you're not using it, pause it, and you can save heaps and heaps of money.
That's a great tip. Keep that in mind, everyone. Awesome. So thank you again, Carey. This was fantastic. We covered a lot of material in a short window of time. And it seems like the attendees gained good amounts of information out of this session. So again, this will be recorded. If you want to tune back in and revisit anything that Carey previously covered, you can do so. The video will probably be up in just a couple of days. And then hopefully we have you back maybe for some future material.
Yeah, definitely. Thank you for having me.
Of course. And at this time, we will complete the session. Have a good rest of your day, everyone. Take care.